Assalamualaikum warahmatullahi wabarakatuh, and very good evening to the panel. I am Muhammad Arman Syahmi bin Azzuadi, Mechanical Engineering student of UiTM Shah Alam. My supervisor for this project is Prof. TS Dr. ZULKIFLI Muhammad. Today, I will presenting my final year project 1, which is IoT-based relative humidity RH control level in air conditioning and mechanical ventilation ACMV system. Throughout this presentation, we will go through introduction, problem statement, scope project, objective, literature review, methodology, expected result, and Gantt chart. In this project summary, present the theory of real-time monitoring of RH control in CMV system via the Internet of Things, which is known as IoT. What is IoT? IoT can be defined as network of physical objects which the thing that embedded in sensor, software, and other technology for the purpose of connecting and exchanging data with other devices over on the internet. Our system will display the collected data to the application in a smartphone, iOS, and also Android. Nowadays, many buildings has built and designed using SCMV system, such as in hospital, supermarket, university, and others. The main problem faced in SCMV system is the mold growth on the air duct, which could be harmful to people in that building. This figure shows the mold growth inside and also outside the air duct. So, from the problem, we propose a system monitoring and maintain the humidity and temperature in the SCMV system at the specific area, thus improve the product quality and optimize the production. Next, the humidity and temperature sensor that have been developed detect excess moisture in a room and enable the ventilation fan to minimize excess condensation. This helps lessen the appearance of mold and mildew and provide a comfortable environment. Then, Wi-Fi communication protocol and overall system will powered by rechargeable battery and USB module. By focusing problem in SMV system, the standard and guideline has been used to evaluate the assessment. The standard guideline is Industry Code of Practice on Indoor Air Quality 2010, Ventilation for Acceptable Indoor Air Quality ASHRAE 62.1. These two tables show the standard and guidelines for temperature as well as the relative humidity. As you can see, these two parameters have different acceptable limits in general areas and also laboratories. In general area, the parameters have a range unit that need to be followed. Meanwhile, the parameter should obey the function of the lab whether need the air conditioning or not. The problem statement in the research are uncontrolled humidity and temperature can be detrimental effect on the product quality, yield, and shelf-life in an industry process. Second, the poor maintenance will cause SCMV system is not functioning properly. It will lead to poor air quality that may affect IAQ, indoor air quality, and pose health risks. The scope of project are to solve the uncontrolled humidity and temperature problem. Second, developing the RH control level in SCMV system with data logger. Lastly, IoT Blink as a platform to display the data monitoring. The limitation of project are it will be a big risk to fail active the system before going out. Second, this is a system microcontroller based and thus be handling with caution. Lastly, if the power up is not given in the form battery or inverters, the system will be useless. Three objectives that need to be achieved in the research are to design the custom system for monitoring in short and long term. Second, to integrate hardware and software for wireless monitoring purpose. Lastly, to test the system performance. According to Rose, etc. al. Lack of cleaning and checking out of heating, ventilation, and air conditioning system HVAC may allow microbial growth which cause rhinitis, bronchitis, and pneumonia. Another study proved that the survival of indoor airborne bacteria and fungi depends strongly on environmental conditions. Next, a review on air quality monitoring using IoT at campus environment showed that those exposed to bad IAQ may experience symptoms of this disease such as irritation of eyes, nose, throat, and fatigue. Gani monitored humidity and temperature using Arduino Uno-based microcontroller and humidity and temperature sensor. Next, for the methodology, first we show the flowchart of the project methodology. So we start the problem statement, identify objective and scope of the project, literature review, system development, system integration, analysis and performance test, and the end. Next, we will discuss more on the methodology. Firstly, we need to initialize the system by establish connection between controller and network. The humidity and temperature sensor will be initialized to collect the data. Then the data will send to the Blink platform for process monitoring. The buzzer will on if the temperature and relative humidity not exceed and below acceptable limit based on ICOP 2010. In this project, the hardware used is Node MCU ESP8266 that as a microcontroller which can control the operation of the RH control level in SCMV system by created programmable coding is burned into it. Next, humidity and temperature sensor DHT22. It is good for 0 to 100% humidity reading and negative 40 to 80 degrees Celsius temperature reading and also low cost. Other than that, the buzzer for alarm and LCD for display the data from the sensor. For the software, we will use IDE, Arduino Integrated Development. The non-MCU ESP8266 board need to be programmed using Arduino IDE, which can be installed in Windows OS. Next, Blink application. It is used for monitoring RH control level in LCMB system, in the smartphone, for Android, iOS, and web apps. This diagram shows the flow of the project from the input until the data implementation in IoT. The data of the humidity and temperature will be sent to the Blink server in a real time using the Wi-Fi protocol that has in ESP8266 board. At the same time, the database will be created in the Blink application for the purpose monitoring RH control level in LCMV system in a smartphone. When the humidity and temperature out of range acceptable limit, the system will alert the user by sending a notification through a smartphone, for example shown in the figure above. For this slide, as we can see in the circuit diagram and the Wi-Fi communication protocol in this system, we can see in order to connect the humidity and temperature sensor, the data pin which is blue wire and will be connected to the ESP8266 board to the D1 pin. Then the data will send to the Blink server in a real time using the Wi-Fi protocol to send notification for process monitoring in SCMV system. For expected result, all components have their own terminal pin that must be connected to the node MCU ESP8266 with humidity and temperature sensor DHT22, LCD, display, and buzzer. Next, a good performance system with high accuracy of humidity and temperature data. Lastly, the data will be sent to the LCD display and Blink, which is through the internet to be monitored and use any platform iOS, Android, and web app. This slide displays the Gantt chart of the project. These are the references that were used in this research. That's all from me For any question and feedback, you could reach me through email. Thank you and happy good day.